Hello, beautiful being, oneness evolving here, out on my front garden, being somewhat accompanied by the neighbour's booming bass. I don't know how much you can hear it, but I will admit that I find it distracting. So, just getting that out of the way. I'm going to show you the garden before I go inside and tell you what I've been writing for God of Me today. So let me show you. Here it is. Last week I said this tree shrub thing was coming out, and now it is. The flowers aren't really out, but they are in bud, and it's been raining, obviously, you can see. And look in here, they're coming out. It's fabulous, and while we're here we have to enjoy this maple. It's so beautiful. The noise has stopped. Isn't that a blessing? However long, it's beautiful. I love silence. So, what else have we got here? Tons and tons of cineraria. It's back, but that's okay. We have cineraria, and we have bright red fuchsia in the background. Hello, beautiful being. It's lovely to see you. Welcome to my garden. My little garden tour before I start telling you what I've been doing this week. Look, the lilies are up, exploding out of the cineraria, not the cineraria, exploding out of the sporaxis. Here they are, and you see how I put wood down here, because I have to keep the sporaxis from smothering them, and this year I've been really successful at doing that. So they're up and they're going to flower and look really cool. And meanwhile, you can see how violent the wind was that we had. The cherry tree is looking very bedraggled. Clearly it's been in flower. And look, a little branch came down. We had some wind. We really did have some wind. So I should put that on the mulching heap. But before I do, look, the rose is just going mad, probably because it's got lots of food. And I have to finish. I deadheaded most of the bluebells last week, but there were a few left, and now they're almost finished. And look at this. Oh, look. So we have fuchsia flowers, but look, there's a shiny black something or other in there, just having a rest. You can't really see, but it's got such beautiful glittery wings. So I'm just taking a moment to appreciate it. And there's still lots of cinerarias coming out. Oh, Julian, hello, sweetie. It's great to see you. On the bridge, no doubt. So here are the flowers. The magnolia is a much tougher flower, so it hasn't been beaten up and completely destroyed by the weather. But you can see that, a lot of flowers have disappeared. And that's just what happens in New Zealand in spring. We get weather coming through. This is pretty cool. The rue has come up. Boom. Last week it really didn't have those tall flower spikes coming up, and now it does. And look at this. I pruned this down hard, and now it's coming up, and that's what the Radomachia does. And it's what I love it for. You just put it down and it comes back and it's fresh and new. Otherwise it gets tall and weedy. So, this is the garden with the rather noisy music in the background, but I'm still enjoying the flowers. Look, there's so many different colours. We've got pink, we've got purple, we've got mauve, we've got a sort of a dark crimson-y thing. I just love these flowers. They're getting a bit old now, but it's so colourful. So I'm going to drop this branch that broke off the tree onto the mulching heap. Obviously that's too wet to do anything with it right now. And take one last look at the magnolia, which is still fabulous even though it's been beaten around by the weather. And then I'm going to go inside and tell you what I've been doing this week. Well and truly down the rabbit hole of understanding matter. Because if you're going to change matter with your mind, you should actually know what it is. And it's remarkable how much we have no idea what matter is. And people think that it's matter, it's solid, it's a thing. You poke it, if you run into it, it hurts you. But actually, the more I learn that that just is not true. Yeah, when you run into it, it hurts you, for sure. But it's not solid. There is nothing there except electrostatic energy, and that was a big surprise to me for quite some time. It was a big surprise to me to realise that this is the nature of matter. Anyway, just getting myself organised here. Is that it's energy. Matter is energy. And when you go actually looking for anything that's solid and real, it's really not there. So, let's put the phone down so I can go hands-free. Now, I'm glad you enjoy the garden, Julian. It's a lovely space. I so enjoy it, and I love being able to share it. So, this week, of course, when I started writing, I went back and looked at what I'd done last week. I always do this. You know, I have to go back, I have to review it, I have to proof it and try and find any typos or things that I missed out. And it's funny, I was writing about charged particles, and I found all these places where I said charged particle, and I missed off the D, or I missed the S off the particles. And it's funny the things you do when you're writing. So I have to go through and clean those things up and make sure that my story reads well and that it's not jumbled and going around in circles and being confusing. Because these are difficult things to explain, even people who really understand them. And I'm doing a different thing because I'm not an expert, but I listen to experts and I try to distill it down to something really simple because I want anybody to be able to approach this information. And it isn't really just about matter. It's about understanding yourself. It's about understanding how the universe works so that maybe you can learn to work the universe instead of feeling like the universe is working over you, right? So I know that seems like a silly idea to think that actually that the universe is made for us to take charge and change things and make differences, but maybe that's actually true, and it's just somehow that we've forgotten that this is true, and we think that everything is about what we accept and understand and believe to be the way it is, and maybe it's not. And so I'm fully aware that it seems a bit weird to be talking about manifestation and electrostatic charge and particles and stuff like that in the same breath. It's like, what the hell has that got to do with manifestation? Isn't that about the law of attraction and positive thinking and, you know, believing it and doing it? And it is. But also, for me, it isn't. I mean, it is. But the problem I had was that understanding all of that stuff, it didn't make enough sense to me. And what I'm learning now, it kind of fills in the gaps because I understand what I'm actually dealing with. And God of Me, by the way, is this project that kind of owns me. And the idea of it is to make this information that has been so huge for me and help me change my life available to anybody who has an internet connection and a phone. And hopefully for very low bandwidth, because the people who, you know, they don't have a credit card because they don't have identity papers and they don't have a bank account and they can't access a lot of the information that many of us take for granted. I have this crazy idea that somehow I'm going to get this information to them. So I'm writing for them. And the people who can pay for it will be able to pay for it. And I'm not going to make it horribly expensive because I don't think that's the point. But that's my crazy business model and the thing that'll be down the track. But right now, I'm just writing the stuff that goes on the website. So anyway, so I realized, I summarized, I went through and I did this thing because I got to a point where we're talking about we're talking about the building blocks of the universe, which is a thing called a Planck spherical unit, and it's a little piece of spinning electrostatic charge. It's tiny, but for its size, it's incredibly powerful. And everything that we can see, hear, smell, taste, touch, experience is made of those things, right? And so it's spinning electrostatic charge. And at that point, I had to go to the internet and say, what is electrostatic charge? Because I honestly didn't know. We all know about static electricity, and if you wear, like a nylon clothing and you take it off at the end of the day, you hear prickly, crackling sounds, or if you do that in the dark, you'll see little flashes of light. Or if you've ever touched a metal doorknob or a rack or a railing in a supermarket and got a jolt out, we know that static electricity builds up, and everybody's seen lightning.
lightning is static electricity. It's built up in the thunderclouds and goes boom down to the earth because it just has to discharge. So everybody has had some experience of static, but what actually is it? So I looked up this definition, and the definition talked about electrostatic charge being potential energy of a system of charged particles, and the fact that there is an electric field in between the charged particles. And up until now, I'd actually defined potential energy. That's in the simplest explanation, which I just got straight off the internet, but I wrote it in my own words, is if you have a ball at the top of a hill, that ball's got potential energy. You let it go, it runs down the slope. That potential energy is expressed in its movement, and if it bounces, if it hits something and makes a noise, or moves something around, or even rubs against something and makes some friction and some heat, that potential energy is expressed, and then it gets to the bottom of the hill, it stops moving, and it's gone. That's it. It's got no more energy. You got to pick it up and move it to give it more energy. Fine, that's potential energy. A system is just a bunch of things that work together, really. And then I spent more time explaining charged particles, because to do that I had to simply explain what a charged particle was. And, we've been talking about protons, and protons have a positive charge, and electrons whiz around the protons, and there are neutrons in there too. They don't have a charge at all. But the nucleus of an atom has neutrons and protons in it, and they sit there and they're held together with a very strong charge. And then weakly attached to this nucleus is these electrons that whiz around in a cloud around them. And that's all you can say. There's these tiny, tiny electrons are whizzing around in a cloud. And so you have that, and normally it's got a balanced charge. It's positive in the centre, negative on the outside. Hello, gorgeous. Lovely to see you, Rita. And that's a balanced thing, but sometimes atoms can lose an electron, then they get a positive charge, and more positive here than negative here. And sometimes they can gain electrons, then they have a negative charge because there's less positive here and more negative there. So that's when an atom becomes an ion, okay? So I explained charged particles. There are other ways it can happen, but that's very common. Most of the stuff that we see and interact with, trust me, there's a lot of atoms that have been ionized floating around in our world. And so it's a very, very common way for an atom to get a charge. Charged particle, right. And then I realized, because I was going to move on from that definition, I thought, oh, God, there's another thing in there that I don't understand, actually, that I can't explain to you in a way that makes sense to me. What is an electric field? I mean, really, we all know that they exist, but what is it? So I had to look that up, and I'm trying to remember what the definition was, but I didn't write that down, but I looked at the definition and I thought, okay, how do I describe this? And that's right, that's what I wrote. You see, I'm having to remember it, which is good. So you have this atom in the middle. Well, you have a particle, never mind, it might be an atom, it might be a molecule, it might be something smaller or something bigger. But you have something, and it's got a charge. And I used an ion, an atom that's gained or lost an electron, as an example. And the point that I had to sort of pick out in my mind and make is the fact that this thing is spinning. Trust me, in this universe, everything spins. And the particle, the thing in the middle, that's got a charge, right? But it isn't just the bit in the middle. There's an area of space around that bit in the middle where the charge also exists. And as soon as I wrote that, I had this picture in my mind of a little dot with a big circle around it. And I thought, I wonder how many other people will be thinking that now, because it's a little bit in the middle and then there's this area of charge around it. And then I thought, no. You can't think about it like that. It says, please don't think about a dot in the middle with a circle around it. No, because that's not the truth. I haven't yet got to describing my version of the truth yet, but here's the first step towards that, because we've already talked about it earlier in the piece. Imagine a big sink full of water, and it's round, right? This is important. A big round sink of water, and there's a plug hole in the middle. Now, when you pull that plug out, the water starts to go down the plug hole, and it's a small plug hole. I want to make it small enough that the water will still go down, but it won't go down very quickly. So here's this big sink of water. You can't see my arms, but it's a big sink of water and this small plug hole. And you pull the plug out, the water starts to go down, and guess what? It spins, right? Now, if you take a leaf, notice I don't say a rubber ducky. A rubber ducky is much more fun, but if you've grown up in the wilds and woods of anywhere and never seen a rubber ducky, you don't know what that is. If you take a leaf and you put that just at the edge of the sink, this big round container with the plug hole in the middle. You put the leaf at the edge of the water, it's not going to do anything. There's water spinning in the middle, but the water on the outside is quite still. I mean, the level's dropping really, really slowly because it's only a small plug hole, but it's spinning. But out here, nothing's happening. So you put the leaf out there, that's really boring. If you bring the leaf, I couldn't think of an easy way to say it. I said halfway between the centre and the edge. And it would probably work. I'd have to test this. My intuition says that more like a third would be better. But you say halfway to a third. So here's the centre and here's the outside and you're in here. So you're closer, a little bit closer to the middle than you are to the outside. You put the leaf on the water there, it's going to move in a circle very slowly. Because that water is going down the plug hole. It's a small plug hole, remember? So it's spinning and it's fast down there, but it's taken its time. And so the water that's maybe a third of the way out from the centre of the edge is moving a little bit. So the leaf is moving a little bit and it's going to go round and round and round pretty slow. If you put the leaf a lot closer to the centre where the plug hole, you're right close to the plug hole, well, it's going to go wee, 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 and then vit down into the void. Of course, it's going to disappear. It's going to go down the plug hole. And last week we talked about the fact that if you look in nature, if you look in the cosmos, you see a galaxy, it's a spiraling thing and it's got a black hole in the middle. If you have a tornado, it spirals. Hi, Mike! And there's a hole in the middle. There's a void in the middle. If you have a plug, water going down a plug, it spins and there's a hole in the middle. If you look at a spinning... There's a theory advanced by this man that I've learnt such a lot from, Nassim Haramein, and he says that protons also have a black hole in the middle. And if you look at his information and digest it and absorb it and think about it, it makes a lot of sense. And these tiny little Planck spherical units, they too have black holes in the middle. Everything that spins ultimately ends up with a void in the middle. If you have a glass of water and you swill it, it goes up the sides. There's a hole in the middle. This is just how nature works. And so the thing about that is that when you spin, the spin is stronger closer to the middle of things, like in that big sink of water. Not doing much out here, but there's a point at which if you put the leaf on the water, it's going to start to be drawn in. The circle gets smaller and it goes in and it disappears down the void. And so everything spins. And the point being the electric field, which is what I was trying to explain, it's strong, close to the centre. It's strong, close to where the so-called particle is. Remember, that particle isn't really anything solid. It's just electrostatic energy. And I because I'm not an expert, I'm still working out how to explain it sensibly. But it's really stronger in the middle. And as you get away from the bit in the middle, that charge that is produced by that unbalanced thing, we've got too many protons in here and not enough electrons out there, that charge drops off and gets weaker, just like when you go out from the plug hole, there's less and less happening out towards the edge of the sink. And then there comes a point where it stops. And physicists actually call that the charge radius, of the particle. So here's the particle, and here's how far away you can go before it goes. And that's actually the size. You might think in your mind of an atom as being a thing like a billiard ball, those round balls that they used to show in chemistry. You have a ball and a stick and a ball and a stick, and it makes a molecule. Well, in fact, that ball is just the area in which there is a charge. It's just the area in which the electrons can be whizzing around, and right in the middle of it is this tiny little piece of concentrated charge that we call a nucleus. Because the protons and the neutrons also are just charges. There's nothing there. And that's the thing that I'm trying to get to, that I'm working to get to, that I'm explaining piece by piece, and why I've bothered to start talking about the Planck spherical unit, because it's the building block. the electrical field, right? It spins. Everything spins. And I have to make a lot more connections yet, because at the moment I've left you with the inner picture of here's a plug hole and it's spinning. But in fact, that particle, the thing that's spinning, is a sphere. It's it's more like an orange, or the shape, when you get an apple and you cut it in half. It's like that, but it goes out the bottom and goes around and comes in again. It doesn't stop. It's never ending. It's a torus. And somehow I've got to find a way to explain all of that in a way that makes sense. And then you think, but hang on a minute, the torus is that thing that I see all over the place and all these spiritual things, and it's the human energy field. You got that. And the human energy field is made up of the same electrostatic charges that are the building blocks of our universe. And here's the other thing that I've got to look at the time, completely blew my mind when I finally grasped it. Now I'm just going sideways and talking about stuff that excites me. But to try and make you understand why I believe this has a lot to do with manifestation, right? So you have all these spinning little charges. It doesn't matter whether it's a particle or a proton or an electron, because those spin too, or a Planck spherical unit, or there's even things that get smaller than that. It never stops. It's a fractal thing, and it just keeps getting smaller, and it also keeps getting bigger. And I guess that somehow someone will do the math one day and discover that it does this as well. So where was I? The point being that the human energy field, yep, it's the same shape. And we think that everything we can touch and taste and smell and, stuff that we think of as matter, as real, that's all made of those things. And it's made of those tiny little bits of spinning electrostatic energy, because somehow it's got enough charge. The charges become unbalanced here. The charges become unbalanced here. This one's positive, this one's negative. Now they'll attract and they'll stick together like a magnet. And so that's how matter actually gets to be. Somehow there's a charge developed, and then there's enough order somehow being created that the matter gets to hold together. And the easiest way to think about that is to think about a flock of birds or a school of fish, or it's called an emergence. And matter literally emerges like that from this vast sea. If you imagine, the ocean, but we're in it, like the air, everything. It's all this ocean of these spinning bits of energy. And some of it's got coherent enough that it's stuck together and made matter, and the rest of it isn't. And it goes right through us. You got just as much of it inside your body as you do outside your body. It's amazing. And so if we can understand this stuff, maybe we can learn to work with it. Because this is what I've come to feel. It's like I feel like I've forgotten what I know. I feel like I should know how to use this. I should know how to access this energy and use it to heal my body, to heal someone else, to create something out of nothing. Because these are all things that have been done by other people before us. There's so many written stories, and not all of them old. Recent accounts of people who've done this stuff. So why not us? And why shouldn't I be curious about it and wonder if it's possible and wonder if I can figure it out? That's what I'm curious about. And for myself, really, that's what God of me has become. It's like, well, geez, if I somehow know that this ought to be true for us, let me go on a journey and see if I can unpack it in a way that I can understand and maybe other people can understand. And then we can look at the how-to. Because I'm also working on the how-to. But it's not anything that I can teach to anyone else yet. So this is the journey. This is what I'm doing in God of Me. It's to give people information that they can use to empower themselves. There's a bit of a passion. It's kind of the only thing that really drives me up. It's to see people grow. It's to see people realize one thing about themselves. Oh, you mean I can be or do or have or whatever that? And I can do it myself, and I don't have to rely on somebody else, or don't have to give my power away quite as much as I thought I did. Yeah, that's the biggest buzz for me. There's nothing else to do. So that's my Gotomy rave today. That's my Gotomy rave this week. Thank you so much for joining me and hanging in there and, my crazy science. I look forward to sharing this with you again next week. The next step. It's like, I don't really know what I'm going to write about, but I've started throwing mud against a wall. I'll see what sticks. I'll put it in order, and there'll be another story next week of the next piece. So if you want more, check it out on Patreon. The link is in the description. Thank you so much for watching, for giving me your precious attention and time. And I will see you next week. Much love. Bye-bye.